Welcome. My name is Jerry Sunarine, and today's lesson looks at how can I create and solve story context for numerical expressions. Before we get into today's lesson, I want to review math word problem strategies. For our students, this is especially important. Math word problems can be very intimidating because of the language used and how to interpret the problem. So here are some strategies that can help students with this process. First, we want to read the entire word problem. This may take several times. We may encourage students to read it multiple times so that they understand what the word problem is talking about. The second step is think about the word problem. Now that they have read it, think about what the problem means. What's the context of the problem, and have them say it in their own words. The third strategy is write on the word problem. This is looking at key vocabulary words, numbers, any information that will be helpful in developing a plan to arrive at our solution. The fourth strategy is draw a picture. Sometimes drawing a picture may help. Drawing a table, developing a equation or mathematical process might be very helpful in arriving at the solution. And the last strategy is to check your answer when you're done. So think about the answer you received and whether it makes sense to the context of the problem. Now we're going to go into our first problem. So the first question is, Miss Hayes has 1/2 liter of juice. She distributes it equally to 6 students in her tutoring group. How many liters of juice does each student get? So in this problem, we would have students pause the video and try to work through the problem on their own. And we want to encourage students to look at the question, annotate it, read it for clarity, and develop a plan. In working at this problem, we will also want students to think about keep, change, flip. So when we're developing our problem, we see that we're starting out with the value of 1/2 liter of juice, and we see the keyword distributes it equally, which in this context of the problem means divide, and it's being divided by 6 students. So here's our original problem. When we have keep, change, flip, we keep the 1/2, we change the division sign to multiplication, and we flip 6 over 1 to 1/6. When we multiply across, we get 1 times 1 is 1, 2 times 6 is 12, and we get 1/12 as our answer. Each student receives 1/12 liter of juice. Now we're going to get into another problem. Here we have a situation, and this problem has 3 steps. And the first problem, we want students to read the entirety of the problem. For this purposes, I'm just going to go straight into the first part of the problem. How many oil changes can Lucia complete during the rest of her workday? When we're looking at the first part of the problem, it's important to look back at what the first part of the problem says. Lucia has 3.5 hours left in the workday. As a car mechanic, Lucia needs 1/2 of an hour to complete the 1 oil change. So going back, we can think about many different ways in which we can help students understand and make sense of this problem. On the next slide, I'm going to show you 2 ways on how to work through this problem, and it might be effective for certain types of learners. Okay, here we go. So here I annotated the word problem and took out key information, and I put it into 2 different ways that students might be able to understand it. One is a table. So every half an hour, we know that every half an hour means 1 oil change, and we do that all the way to 3.5 hours, which is key to the problem, which tells us 7. We can also think about this algebraically. we can say that 0.5x equals 3.5. Again, 0.5 equals half an hour. The 3.5 is the hours left in Lucia's shift. And we follow the steps, we still get 7 as our answer. We're going to move down to some other parts of the question. Now we're going to go into B. Here, Lucia can complete 2 car inspections in the same amount of time. It takes her to complete 1 oil change. How long does it take her to complete 1 car inspection? So we would encourage the students to pause the video, think about the problem, and we will show how to work through this. Here, we see that 1/2 is the key value. So 1/2 is the oil change, and we know that 2 values can be taken from there for the car inspection. Here we do keep change flip, so we want educators to elaborate on how to do keep change flip for our students. We keep the 1/2, change the division sign to multiplication, and the 2/1 turns into 1/2. We multiply it across, and Lucia takes 1/4 hour to complete a car inspection. Finally, our last part of the problem, how many inspections can she complete in the rest of her workday? We would have students pause the video, and here we can develop 2 different strategies, one being a table and the other is algebraic. So with the table, we just continued and made an extra column. So here I just added an extra column for a number of car inspections. We know that every 1 oil change means we can also do 2 car inspections. When we do this, we notice that there's a pattern. We can have students identify what the pattern is, and if we wanted to continue the chart in the table, how this would look like. So here we see that in 7, the number of oil changes, which is 7, the number of car inspections is 14. So we just follow the pattern and we get our answer. Same thing, we can think about it algebraically. Since we know Lucia can complete 7 oil changes in her workday, and every oil change equals 2 car inspections, we can do 7 times 2 gives us 14. So both ways gives us the correct answer. Next, we're going to look at another problem. In this problem, we see that Carlo buys $14.40 worth of grapefruit. Each grapefruit costs 80 cents. The first part of the problem tells us how many grapefruits does Carlo buy. So we would encourage our students to pause the video and think about how they can do this by creating either a table or doing this algebraically. Here is a way we can do this with the table. There are a lot of steps, but this will give students an opportunity to think about how many grapefruits equals the cost. We also have an algebraic breakdown of the problem. Here we are dividing the $14.40 by 80 cents. We multiplied everything by 10 so that we are not dealing with any decimals. And when we divide 8 into 144, we get 18. Carlo buys 18 grapefruit. We still get the answer over here as well. The last thing is, at the same store, Kyrie spends 1/3 of as much money on the grapefruit as Carlo. How much grapefruit does she buy? So when we're thinking about the question, we know 1/3 is less than Carlo, so we can have students think about, is Kyrie's answer going to be larger than 18 or smaller than 18, and by how much? So here is just an explanation. So we know that 1/3 is going to be a key information in the problem. This means we divide by 3. So we take the answer from the first part, which is 18, we divide it by 3, and we get 6. Kyrie buys 6 grapefruit. Finally, we're going to go into our summarization. So how can I create and solve story context for numerical expressions? So we want to read the math story for understanding. We want to think about select key information from the story. And lastly, develop a table or algebraic equation to solve it. So here are some examples that demonstrate this. Hope this was helpful, and have a great day.